Hey, welcome. My name is Martin and I'm a security researcher at OpenZeppelin. Today the idea will be to quickly explain the vulnerability that our team recently uncovered in Libra's Move IR compiler, which you have probably read about, so we won't do a deep dive. If you want to go in-depth in this vulnerability, how we uncovered it, how the Libra team fixed it, and any other details, you can go straight to our blog post. So the idea of this video is just to do a quick recap of it. The really good thing about this is that you need almost zero knowledge about Libra and the internals of the MUI compiler to understand what is going on and what is the impact of the vulnerability. In a nutshell, to put it simply, the vulnerability allows for anyone to create modules that can deceive users. That means that the modules will behave differently from what you as a regular user would expect. That is because an attacker could have the chance to disguise inline comments as executable code. Let me say that again. You can disguise inline comments as executable code. So there will be code that looks like it's going to be executed, but it will actually not be executed because the compiler will treat it as part of an inline comment. Such as this. Let's take a look at these two modules. Can you spot the difference between them? Right, no? Well, if you can't, you could have been tricked by this vulnerability. This is how modules are rendered in GitHub. But let's take now a closer look at these two modules and see what's the actual difference between these two, because as they are rendered, we cannot spot any difference. If we take a closer look, we see that there is a slight, tiny difference between the two. We see one byte that is different. The exact byte that is different is this 0A and this 0G in the second one. This 0A represents the line break between the inline comment and the resource declaration, and this 0D also represents a line break, but a different type of line break between this inline comment and this resource declaration. This 0A and 0D, you can actually know them as /n and /r, or for instance, as LF and CR, okay? So that is the actual difference between the two modules. So the thing is, we do see them as equal. So if we do see them as equal, we expect the compiler to treat them as equal. That means that, in other words, they should produce the same bytecode when compiled. This is the function that takes care of identifying and removing inline comments from the source code. Apparently, from what we see, don't get scared about this Rust code. No need to understand it in details. Just make sure you see that they are trying to capture the inline comments with a regular expression and identify the CRLF, LF, and CR as valid endings of inline comments. Though I must warn you, there are other valid Unicode line breaks that they should be taken care of, that even if this function had worked properly, they would have been still missing other type of line breaks. But let's for now focus on what this function is trying to do, just that. So apparently this function for modules that have an /n or /r at the end of an inline comment, they would detect it at the same. You know, these two modules that we saw should produce the same bytecode from what we see in this function. But that is not the case. Let's take a closer look at the compiler and what the output is. So, in this case, we have a module that has a LF between the inline comment and the resource declaration. This is the output. What you see here is the output of the compiler. Never mind, don't need to pay close attention to the exact numbers. It's just the bytecode. For the sake of comparison, we need to know which is the bytecode produced for a module that doesn't have any resource declaration, and this is the bytecode produced. So afterwards, what we did is, okay, instead of having a /n, let's try the same module, but with a /r and see what happens. And surprisingly, we found out that the bytecode produced for the last case is the exact same bytecode that was produced for the case of a module without a resource declaration. That means that even as we saw in this function, even if the parser is attempting to detect this /r at the end of inline comment, it is failing at that. We can validate that in this way. We have proved here that the bytecode is the same. That means that this /r is not being detected, and this module is just treated as if it didn't have a resource declaration. So again, that is the function, and even though it looks like the compiler is not recognizing the CR character at the end of an inline comment, and you can play with that in this, following this URL. It will just take you to the Rust playground where you can play with this function, different inputs, and see what happens. Okay, so to sum up quickly, it was possible to disguise inline comments as executable code, as we saw in this module. That resource declaration would have never been executed. That means that that module is like it's empty, even if it looks like it's not. As I told you before, there are more Unicode valid line breaks that the parser wasn't even attempting to detect, such as, for instance, ls or ps, and we see here two modules as rendered in Visual Studio that have the first one an ls character between the inline comment and the resource declaration, and the second one has a ps that we are obviously not seeing between the inline comment and the resource declaration, and these two modules would have been compiled as just empty modules. So, which are the potential exploited scenarios? It is hard to tell just because Libra is not live yet. The Move compiler and the entire Move language is under heavy development right now. So the exact features and the possibilities that we will have in the Libra platform are not entirely clear yet, but we can think of at least these 4 scenarios that we will see now. We can think of a faucet that appears to mint assets in an exchange for a fee. Yes, so you would provide a fee, and supposedly this faucet will give you some assets, but it will actually not mint any asset at all. We can also think as a wallet that claims to keep deposits frozen like an escrow and release them after a certain period of time, but actually it will never release them. We can think of payment splitter modules that divide assets, but at the end of the day, they don't. Or we can think of modules that treat sensitive data in a way that it is not the expected one. You could think of modules that claim to hash or encrypt data, and they don't. Again, we don't know exactly what are the features of Move and the main use cases of Move and the Libra platform yet, but these are some cases where this vulnerability could have caused a huge impact. Luckily, it's been fixed. In this commit, the Libra team has been really responsive to us. They did a quick fix, and for more details, you can go right into the commit or read our technical description in our blog, where you will find everything that I have told you here and many more details about it and how it was fixed, when it was fixed, and so on. So I really recommend you to go over that blog post. It's super interesting, and yeah, that's it. Thank you very much for joining us, and I hope you have enjoyed, and see you next time.